Now these are what we've been talking about are variable specific heats type problems. What happens if you do constant specific heats? What happens if you constant specific heat? Well, what we could find out, remember we're going to replace delta U with equal to C sub V delta T, and we're going to replace delta H with C sub P delta T, and we're going to replace delta S with C sub P natural log of T2 over T1 minus R natural log of P2 over P1. What do we do in this case? Well, we could find out that the molar specific heat total is equal to the summation of I is equal to 1 to J of Yi times C sub V I of each component. So you figure out, here's the C sub V of my component. There's only 30% of that component, so I take 30% times that C sub V, and I keep adding that up with all the other components till I get the total components. If I want to find this on a mass basis, I is equal to 1 to J of mass fraction of each component times C sub V of each component. And the same thing works here with C sub P. So I'm going to say the same thing for C sub P. I don't want to go rewrite that. Don't want to waste your time. You can do this. You know how to do this. It's the same. Okay? And we know that the ratio K is equal to C sub P all over C sub V. It's equal to C sub P bar all over C sub V bar. This is the same thing. Same thing. Okay? So, what could we do here? This is where it comes down to what could we do. And it becomes very, very, very complicated. All right? If you don't understand how to go about this, you're going to feel like there's lots of different ways to make things happen. Let's say I want to find delta U. Okay? Well, I could do this. I could say U2 minus U1 is equal to, let's go capital U2 minus U1. U2 minus U1 is equal to the summation of I is equal to 1 to J of the number of moles of each component times U2 bar minus U1 bar of each component. Okay, now U2 minus U1, this is going to have units of kilojoules or BTUs. And we should have this because U bar is going to be in BTUs per pound mole, and we're going to take it times the number of pound moles, and we're going to add that all up. That's one way you could find it. Or we could say U2 minus U1 is equal to the summation. I is equal to 1 to J of the mass of each component times U2 bar minus U1 bar all over the molecular weight of each component. That's another way to do it. We want to do things in mass basis, we can do it in mass basis. Okay? Or we could say that U2 minus U1 is equal to the total number of moles times the summation of I is equal to 1 to J of Yi times U2 bar minus U1 bar I. Okay, so what's happening here? Now what I'm saying is I'm going to figure out what contribution that we're going to have percentage-wise here, Yi times this, and we're then at the very end multiply it by the number of moles. Now look here, number of moles times Yi, what is that equal to? That's equal to number of moles of each component. So this is 1, 2, 3. 3 and 1 kind of match up. Okay, it's a similar way of doing things. Or, way 4 is I could say U2 minus U1 is equal to the mass total times the summation of I is equal to 1 to J of the mass fraction of each component times U2 bar minus U1 bar all over the molecular weight of each component. Completely acceptable way to do things. 4 ways to do the same thing. And you and your neighbor and somebody else doing this exam may figure out a different way to do it. But if it all has to match up the same, and I will please trust the units here. Please trust the units here, and I will make damn sure that on the exam that my units are correct. But you make sure that when you look at this, U2 minus U1 is always going to be in units of kilojoules, or always in units of BTUs, and you can always check your work that way. Okay, these methods here are going to be variable specific heats. Or we could do way number 5. We could say U2 minus U1 is equal to the summation from I is equal to 1 to J of the number of moles of each component times C sub V bar of each component times T2 minus T1. That's a way to do it. That's a way to do it. We could do it that way. Or way 6 is we could say U2 minus U1 is equal to the summation of I is equal to 1 to J of the number of moles total times Yi times C sub Vi bar times T2 minus T1. Okay. Or way 7 is we could say U2 minus U1 is equal to the summation from I is equal to 1 to J of the mass of each component times the C sub V of each component times T2 minus T1. Now we're doing things on a mass basis. Or way H says you can do U2 minus U1 is equal to the summation of I is equal to 1 to J the mass total times the mass fraction of each component times C sub V of each component times T2 minus T1. Okay. Or we could do way 9. We could say U2 minus U1 is equal to the mass total times the specific volume, specific heat at constant volume total, which we would have to calculate by taking C sub Vt is equal to the summation from I is equal to 1 to J of the mass fraction times the C sub V of each component times T2 minus T1. Okay, we could calculate that, and then because the temperatures of the mixture is going to be the same at 2 and 1 of each component, it doesn't really matter. We could do it that way. Or way 10 is we could say U2 minus U1 is equal to the total number of moles times C sub V bar T, which we'd have to calculate using C sub V bar T is equal to the summation of I is equal to 1 to J of Yi times C sub Vi. And take that times T2 minus T1. Okay. All of these ways here, these are constant specific heat ways. All of them get you the same answer. And I probably missed some here. These are just what came to the top of my head here just doing this lecture. Okay? You must, when we're doing some problems here, you must be comfortable enough with this idea of how to add things up that you can see through and look at the method that we are going to use to be comfortable to use one of these 10 methods, depending on what the problem statement is trying to say. Okay? Now, here's some other things that you need to know. You need to know that sometimes we might say the word binary mixture. Remember, binary is zeros and ones. It's basically meaning two things, zeros and ones. Binary mixture means a mixture of two things, nitrogen and oxygen, carbon dioxide and carbon monoxide, one of the things. So if you see binary mixture, it means two things. That's a vocabulary word. Okay. It's just nothing really new here. It's just new vocabulary, new ways of looking at things. But it still comes back to those same old tried and true. We're needing to find the delta U's. How do we find the delta U? How do we find the delta U for each component that we have here? Okay, that's really the lecture material for today. I'm going to now do a problem and have you help me answer this problem in the next segment.